Hello, everyone. So, as you can probably tell, the sine rule is pretty self-evident. It's pretty obvious when you need to use it. You know, when you have two sides on one angle, two angles one side, you know, and the opposites fit into place, it's very easy to use it. But there are issues that can arise where you mightn't be able to use it. Okay, and the main way it can cause trouble is when a load of the information is made. Mainly, I suppose where it comes into mainly, it's mainly when you know the sides, but the angle is missing. Okay, it's mainly where you know the sides, but the angle is missing. Okay, that type of scenario. Okay, and the best way to kind of, I'm going to put down the formula and then I'm going to prove it to you. Okay, and you do need to know the proof. So this is very important that you watch this video a few times. It hasn't come up in a couple of years, this proof, but it is weird proof. Okay, so I'll just kind of explain it to you for want of a better word. So in its most standard form, and remember, this will work for any side, any angle. Okay, so it'll work for any side, any angle type of scenario. Okay, so first of all, I'm just going to change these things around just a little because I want to kind of go with the most basic. Okay, so given a triangle like this where you know three of the sides and an angle. Now, obviously, you could use the sine rule here, but this allows you to kind of play around with it. Okay, basically, a squared, the length of a squared, is equal to the length of b squared plus the length of c squared minus twice the product of b by c by the cos of a. Now that looks crazy, but it's a pretty nifty piece of work because it allows you to factor in more unknowns to get the answer you want. Okay, so I'm going to show you the proof of it. We'll come back to it and then see for yourselves does it kind of make sense to you. So basically what we're saying is that one side squared is equal to the sum of the other two sides squared minus twice their product by the cos of the angle in between them, hence the cosine rule. Okay, so I'm going to show it to you. So in order to make this work, we're going to go to a coordinate geometry page. Okay, simple as that. And as you can see here, I've just drawn an axis. Okay, this, most importantly, is going to be origin. Okay, so this is 0, 0 right here. Okay, now watch. All I'm going to do, okay, is I am going to place 1 point on my line, okay, and wherever I put it, let's go say put it here, okay, that's going to be the point B. Okay, this point where the origin is, that's going to be the point A. Okay, so, and this is the cool bit. I'm going to make another point C out here. Okay, so I'm going to join those three to make a triangle, and as you can see, it's an obtuse triangle. Okay, so this obtuse triangle is made up of, I'm just going to take the shine off there for a second. This obtuse triangle is made up of the origin, contains one of the vertices, a point on the x-axis contains the other one, and then the third bit is just out here. So it's obtuse. This angle is obtuse. We can be sure of that. Okay, so this is the angle B, which means this is the side B. We use a different color. See, does it work? There's B. Okay, because it's opposite the angle B. This is A, so this is the side A, and this is C, so this is the side C. Remember, the angles are in here, A, B, and C. Okay, angle big C, big B, big A. Okay, that means their sides are opposite, just like we're doing with all the other stuff. So that means that this coordinate here, if that's a distance of C, then it's C0. Okay? You wouldn't argue with me on that one, would you? Your distance is C, and there's no y component. It's just C0. Now, this is the really, really, really cool bit. Okay? I am going to get a triangle. And just I'm going to get this perfect. I'm just going to draw a circle. Okay, but it's the important thing. The circle must go through C. So C becomes the radius of the circle. Does it make a difference where else it goes, as long as it goes through C? Okay, so you see that. Okay, so okay, so I've transferred it on to kind of just a white piece of paper just so I can go through it again, because I did find that this stuff is just, it doesn't look right. So I've used 0, 0 and the line B to create my unit circle. Any coordinate on the unit circle can be given in terms of cos A, cos A sine B. Sorry. Cos A, sorry, sine A. Okay? So, where this is obviously A. Okay? So, we don't know the length. We don't know if it's 1 unit. So, we always put, this case is going to be whatever radius that is times the cos of A, and whatever radius that is times the sine of A. So that's that one. Now, this is where it gets really cool. Okay, is there a way of expressing the distance between this point and this point? Well, there is. Because what coordinate geometry tells us, it tells us that the length of A is going to be equal to the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared, which means that A squared is equal to, just get rid of the root, x2 minus x1 plus y2 minus y1. So let's put them in and figure it out. So A squared is going to be equal to x2 minus x1. Okay, you can do this any which way you want. C is x2 and that is x1. C minus B cos A plus 0 minus B sine A to be squared. So suddenly that looks a bit better. Because remember, what are we trying to get at? We're trying to get to, and I'll write it up here at the top, A squared is equal to B squared plus C squared minus 2BC cos A. Okay, I can definitely see the cos A here. Okay, so we're definitely getting it. Now, multiply out the brackets. So let's move it over this way a bit. A squared is equal to square the left. Oh, look at that. Got the C squared. Square the right. That's going to be, let me think, B squared cos squared A. Multiply them together and double it. Minus 2BC cos A. Oh, look at that. We're close, but we have this thing here. The great thing is, square the left is 0. Square the right is the only thing you have to worry about. Plus B squared sine squared A. Because multiply them together and double it becomes 0 as well. Oh, I have a lot of the things that I need. So I do. I have a lot of the things that I need. So I'm going to take what I need, c squared minus 2bc cos a. Now the only thing I'm missing is the b squared, but I can see it, but it's stuck in these two things. So let's factorize it out of them. Right, we're so close. Look, I have my minus 2bc cos a. I've got my c squared. There's my b squared. If I could only get rid of this. Well, the magic of this all, your log tables. The cos squared of a plus the sine squared of a is magically 1. So this is 1. So now 1 times b squared is b squared. A squared is equal to b squared plus c squared minus 2bc cos a QED. And that is it. Okay, perfection. Absolute perfection. Okay, it's a tough one, lads. It's not for the faint-hearted. Okay, so how do we do it again? Create a triangle with one vertex on 0, 0. Extend one to the right into the first quadrant along the x-axis, call it C0. Extend one to the left into the second quadrant, call it B. But B can be written in terms of cos A, sine A, and then you're basically just doing your coordinate geometry on it. Okay, now what use is this? Do I hear you shout? You can rearrange this in multiple ways. Okay, absolutely, you can rearrange this. You know, it can be a squared is equal to b squared plus c squared. It can be b squared is equal to a squared plus c squared. You can do it any which way you want, and then you can rearrange it to get the cos on its own. Okay, and then you can get cos inverse. It's very easily done. Okay, manipulating the formula around. Very easy, very handy, very accessible. Okay, I'll do one quick question just to show you how powerful this is and how you go. Okay, so just a very quick question to show you how powerful this piece of kit is. Triangle. Let's say that's 50. That's 10. That's 8. That's x. Find x. Well, it's not a right angle triangle that I can see, so I can't use Pythagoras. Can't use the sine rule because even though I know 3 things, I don't have opposites. I don't have that angle or that angle to help me. So I can only use so x squared is equal to 10 squared plus 8 squared minus 2 times 10 by 8 by the cos of 50 degrees. Look how quickly that was done. Look how quickly that was done. So 10 squared plus 8 squared minus 2 times 10 by 8 by the cos of 50. And then root the answer, 7.82. Don't forget to root the answer. Look how quickly that was. That's insanely quick. Okay, so we'll play around with this the next day. Thank you very much. Goodbye.